Hi, welcome to another session of Circuits and Networks. In today's class 10 under GATE exam, we are going to see problems and solutions on electrical networks and circuits. So in the first problem you can see, the problem was in GATE 2018 for 2 marks. The equivalent impedance Z equivalent for the infinite ladder circuit shown in the figure. So you can see here 9 J ohms, 5 J ohms, minus 1 J ohms. All these passive elements are connected in T and pi fashion, and this is repeated for infinite. So what we have to do, this infinite ladder network has to be reduced to common form. What common form? You can see you have on the right hand side Z equivalent, and you have 9 J ohms, 5 J ohms, and minus 1 J ohms keep on repeating over the successive ladder arrangement. So just replace this 9, 5 and minus 1 with Z equivalent. So when you look into the options, these are options given. So we'll go with the solution. The solution, as I told you, I have reduced this ladder network to this network by replacing the 9, 5 and minus 1 with Z equivalent, because it is getting repeated like this. Now you can see this Z equivalent is parallel with J5 and minus J1, and that is in series combination with 9 J ohms. So Z equivalent on RHS will be equivalent to these two parallel arrangements in series with 9J. So the parallel will lead you as 5J minus 1 will give you the value as J4 multiplied with Z equivalent 4 divided by Z equivalent plus J4. This parallel combination is in series with 9, that's why plus 9J. Now what you do, take J4 plus Z equivalent in the denominator and multiply on the both sides. As common factor, you can see Z equivalent multiplied with this denominator as well as J4 Z equivalent plus J9 multiplied with this denominator. After multiplication, we are going to see that Z equivalent J4 and Z equivalent J4, it is getting repeated. So this cancels out, and 9J multiplied with 4J will give you as value minus 36, and 9J Z equivalent is kept as it is. Now let us frame this equation into this form, that is Z equivalent square minus 9J Z equivalent plus 36 is equal to 0. So roots for this quadratic equations can be obtained with the help of formula minus b plus or minus under root of b square minus 4ac by 2 into a. So assuming the value of Z equivalent as x square, so with that you're going to get the roots for this quadratic equation. As you can see, minus and minus will go as 9J plus or minus under root of this 9J of minus square minus 4 into 36 will give you the value as under root minus 225 by 2. In fact, this value will be equivalent to J9 plus or minus J15 by 2. If at all I take the positive sign, I am going to get 15 plus 9 divided by 2, that is 12J. If at all I take the minus, I'll get the value as minus 3J ohms. So when I'm going to look at the options, here you have option A as J 12 ohms. So this is the right answer. It's a very important problem which was asked in GATE 2018 for 2 marks. Now see the next problem. Figure here shows the waveform of the current passing through an inductor of resistance 1 ohm and inductance 2 ohms. Sorry, 2 henries. The energy absorbed by the inductor in the first 4 seconds is dash. So this question was asked in GATE 2003 for 1 mark. I think it's a typical question. You need to focus on the procedure in order to obtain the answer. Exactly, the resistance and inductance are the parameters where the current waveform is shown, and the current is 6 amperes and it is ranging from 0 to 4 seconds, which is based on x-axis. From 0 to 2 it is linear, from 2 to 4 it is constant. So this is the waveform given to us for RL circuit. For this waveform, we need to find out the energy absorbed by the inductor in first 4 seconds. So how to do this? The options which are given as 144 joules, 198 joules, 132 joules and 168 joules. So from the given waveform, try to obtain the solution for I of t. I of t is equal to 3t. How 3t? Just apply the formula of y is equal to mx passing through the origin. So it becomes y of t becomes I of t, which is equal to the slope for 6 and 2 it is 3, and y equal to mx, m value is 3, x value is t, that is why it is 3t, and this is obtained as an equation for current for 0 to t less than 2 seconds. This is the first important step. Then from 2 seconds to 4 seconds the value is 6, it is constant. So 2 seconds to 4 seconds is constant. So from looking into the waveform, you need to deduce the equation for current for RL circuit. Okay, energy stored in 2 Henrys is given by integration of 0 to t power p of inductor dt. So the power you can estimate for inductor as voltage across inductor multiplied with current through the inductor. The current value is given as 3t, and the voltage across the inductor is given by VL of t is equal to L di by dt. Now with this information, we have the value of inductor, we know the value of I of t, that is 3t. So the interval is from 0 to 4, that is what is asked in the problem. So 0 to 4 it is written like this. Now just substitute the values. So you can see I have taken the interval from 0 to 2 seconds first. So 0 to 2. VL of t is nothing but L di by dt. L value is 2. D by dt of I of t is nothing but 3t. Multiplied with I of t. I of t here again from 0 to 2 is 3t and dt as it is. Plus again from 2 to 4, what is the value? The value is 2, that is inductor value. Di by dt is nothing but 6, it's a constant, and you have I, which is also another constant, dt. Now just apply the integration to these two individually. What we are going to get? See this d 3t by dt, it will give you the value as 3 into 2, that is 6, and you have 3t dt, again 3 multiplied with 6 it becomes 18, and you have integration for t dt, it becomes t square by 2 plus what is this value? The derivative of constant is 0, so this entire integral will go value as 0. Let me write for you this once again. So you have 3 taken this outside, 2 taken outside, and 3 again taken outside, and you have t square by 2 is the integration of t dt, and you have upper limit as 2, lower limit as 0, plus this value as 0 as it is. Now this becomes 3 into 2, 6 into 3. Now this becomes what? 3 into 2 into 3 divided by 2. So in fact this becomes 3 into 3, 9. And you have upper limit as 2. So 2 square minus 0. So what will the limit give you the value? It will be nothing but 36 joules. So this I'm treating as equation 1. And I'm not done with the answer because also resistance is mentioned. So we need to also estimate the energy dissipated in the resistance of 1 ohm. Again it is ranging from 0 to 4 because of the given interval. The value of this power integration will give you the energy, that is I square RT. So I square R value is given as 1. I square is nothing but the value of I of t for 0 to 2 seconds and from 2 to 4 seconds. So like that, carefully apply the integrations. So I have from 0 to 2, I have 3t for 0 to 2 seconds. So this becomes 3t square dt plus 2 to 4. You have I square r dt, r value is 1 again, and the value of this 6 becomes 36 dt. In fact, this when you rearrange, you're going to get as 9t square dt integration of 0 to 2 plus 2 to 436 dt. This will give you the value as 9 getting outside. T square integration becomes t cube by 3. The upper limit is 2, the lower limit is 0. And this 36 when goes to outside, the integration is applied to dt. So it becomes t, upper limit 4, lower limit 2. So this substitution will give you the value as 96 joules. And this I am framing as equation 2. So overall the energy absorbed by the inductor in first 4 seconds for the RL network when current waveform is supplied through it is obtained to be 36 plus 96 is equal to 132 joules. Very interesting problem. In fact, this was asked for 1 mark. You should have asked for 2 marks. But anyhow, sometimes this is how the in-depth of the problem they are going to frame the question, such that one should know how to find out the energy calculations or power calculations for inductor as well as resistors. It's a very interesting problem. The option is C here. The next problem, for the circuit shown in figure, V1 is equal to 8 DC, I1 is equal to 8 amperes DC. The voltage VAB in volts is dash, round off to 1 decimal place, and this was asked in GATE 2023 for tripling paper for 1 mark. How the circuit was? Circuit was like this. Very interesting problem. First, you need to collect the data which is given here. So you can see, in order to consume students' time, they have rearranged the problem in this fashion. I1 is given, V1 is given, whose values are not directly given, but they are given in the form of data. That's why we have selected here in the form of data. Now, once the data is known, you can easily find out the value of voltage which is supposed to flow in 3 ohms. Now, observe point A and point B, where you have 3 ohms, and plus and minus is the value of voltage measured across 3 ohms. That 3 ohms is again in parallel with 3 ohms. So that is a careful observation what you need to make over here. Between A and B, 3 and 3 are in parallel. Also, point B, it is shorted till this point, and another branch is having 2 ohms, which is connected in parallel with again 2 ohms. So this 3 and 3 are in parallel, and again this 2 are in parallel. So for this, let me calculate the parallel combination of these two resistors. That is 3 into 3 divided by 3 plus 3 will give you the value as 1.5. Again, 2 into 2 divided by 2 plus 2 will give you the value as 1. Just redraw the given circuit like this. As I told you, 3 and 3 will give you the value as 1.5, and this 2 and 2 parallel will give you the value as 1. Okay, now carefully observe, this 8 volts is connected on top over here before 0.5 ohms, and the bottom is connected directly to B. In fact, zero point 0.5 and 1.5, they are in series, and that combination is parallelly arranged to 8 volts. And since it's a parallel circuit, 8 volts will dominate over this entire branch where the current is going to flow. So the current which is supposed to flow in 1.5 ohms, it can be obtained by calculating the voltage divided by the total branch resistance. So that current in 1.5 ohms can be obtained as 8 divided by 0.5 plus 1.5, that is 8 by 2 equal to 4 amperes. Now 4 amperes is the current flowing in zero point 0.5 ohms as well as in 1.5 ohms. What is the requirement? Requirement is the calculation of voltage across A and B. So you have resistance as 1.5 and current as 4. So VAB will be equivalent to 4 into 1.5, which is equal to 6 volts. So this was asked for 1 mark in GATE 2023 for triple paper. Okay, let us see another problem. In the circuit shown below, the current flowing through 200 ohm resistors is dash milliamperes, round off to 2 decimal places. Again, this is a question what framed for EC stream for 1 mark, and this was also asked in GATE 2023. And this is the circuit it looks like. So current I, it is flowing in 200 ohms. That is what we need to calculate. By looking into the network, you can apply mesh analysis, you can apply node analysis to get the answer. If at all you apply for node analysis, you can see you have one node here, another node over here, and the rest of the nodes is a common node. So I can have V1 and V2. In fact, V2 will be equivalent to the whatever the value of voltage you are going to calculate for V2. The current I will be equivalent to V2 by 200 ohms. This is one way of getting the answer. Or you apply the mesh analysis. Take this one as loop 1, loop 2, and loop 3. In fact, loop 2 and loop 3 has a common 1 milliamperes. So this becomes the super mesh. So this is how you have to introspect the given problem. So how easy you can solve this problem in a fraction of seconds or minutes is our main concern. By looking into the circuit, you can see 1 milliamperes source is connected parallel with 1 kilo ohms, and that is in parallel arrangement. So if at all I convert this with the help of source transformation uh, to a voltage in series with 1 kilo ohm like this, then it would be easy for me to find out the current I. So what I have to do, I have to apply KCL at node V. Now when you apply KCL here, you have node voltage V and you have the branches like this. So V minus 2 by 2k plus V by 2k minus 1 milliamperes plus V plus 1 by 1 plus 1000 plus 200 will give you the value for node equation at this particular node V. This you simplify like this, taking the V on one times, constants on other times, you are going to get the value of V, which would be equivalent to 7 by 11 volts. Once we are done with V over here, I can get the value of I, that is V plus 1 by 1000 plus 200 like this. This substitute the value of V, you're going to get the value of current, which is 1.36 milliamperes. So you can see how basic questions are framed for 1 mark in recent GATE exams. So you need to prepare accordingly by looking into the basics of electrical circuits and networks. I hope today's class was interesting. Especially we have seen the problem which was asked for triple in GATE 2023 and GATE 2023 for ECE stream. I hope you like this video. Please share this video among your friends and subscribe to my channel, and please press the bell icon